Tēnā koutou katoa, he toira o I Otago whakaihu waka ko Hannah tōku ingoa. Today I'll be talking about residential heating demand and the related emissions and how we mapped one number nationally to different regions across New Zealand. So this work I did alongside Michael Jack and Gareth Gretton. So we'll start with why residential heating. So we have here an image from ECA's energy end use database, and you can see that we have transport, mobile mode of power is the largest energy use, followed by industrial heating and cooling, and then third we have residential heating and cooling. So that is the third largest contribution to New Zealand's energy end use. And so we already have a lot of decarbonisation strategies in place for transport and industrial heating, but not as much as being done for residential heating. And we only have quite general information about residential heating. So some of that we do know, for example, industrial heat, there's the regional heat demand database where they have a bunch of data and have looked into lots of different sites and how many boilers there are, and they're working to decarbonise a lot of those across the country. So they know quite a lot about the regional spread of how industry heat is used. For residential space heating, we know that the annual kind of national demand is around 5.84 terawatt hours in 2020 from that in-use database, but we don't know much about how that is spread across the country. Yeah, the in-use database also separates this into the fuel use, and so you can see there. But again, the fuel use varies across the country with availability of fuels, and so we wanted to figure out what that would look like. So our main questions were, how is residential heat distributed across the country? What fuels are used in each region? How the greenhouse gases related to residential heating are distributed across New Zealand, and what would happen if all of the heating across the country was electrified. So to do this, we used a top-down method. So starting with that annual and national heating demand total from the ECA in-use database, we used environmental temperature data from NIWA to use heating degree days to calculate that heating need based on the different climate temperatures across New Zealand, as well as the number of dwellings per region to get an estimate for floor area of all the houses in one area in each region. So that's from the census data, and we used just an average floor area for each dwelling multiplied by that. So that we also assumed that each house met the minimum building performance from the building code. So now that we had a monthly and regional heating demand, we could further dissect this by fuel type using heating device efficiencies from ECA's time study. And then we also used some census data that asked respondents what the main type of heating device they used in their house. And so that meant we could distribute those national totals for each fuel by the device prevalence in each region. And so once we had the monthly and regional heating demand by fuel type, we were also able to use emission factors for each different fuel type to calculate the regional greenhouse gas emissions related to residential heating. We used a similar approach for domestic hot water, but instead of those environmental temperatures, we used ground temperatures, which have been found to be a good indicator of incoming cold water temperatures. Because there isn't like heating device data for like hot water the same way that we had for the heating device type for residential heating, we assumed a similar split between electricity and gas because of the prevalence of that availability in each region. So we also validated our data and our calculations with measured electricity data from the Electricity Authority. So you can see here along the x-axis we have what we estimated was the electrical space heating demand, and on the y-axis the measured Electricity Authority residential consumption. So we have some regions there, Auckland, Canterbury, Wellington, and Dunedin, and you can see we got pretty good agreements. So these are all monthly values plotted against each other. Some other cool features is the y-axis, or the y-intercept on these, represents the kind of base load electricity outside of that seasonal variation in space heating. So some of our results, to start with, we had our annual specific heating demand for each region. So this pretty much follows the temperature climate variations across New Zealand. So this is the energy per unit of floor area. And so naturally, as we go further south, it's colder, we need to use more heat. And so for the annual heating demand totals, Auckland is the largest because it's where most of our population is. However, Christchurch has, I think, 4 times less population, and it's still pretty comparable there in the space heating demand. And so we also found that the population-based estimate, where we're just looking at population only, it overestimates by up to 100% in some regions, and it can underestimate by about 60% in some regions. And that's because it doesn't take into account those different temperatures, which obviously influences our heating use. Cool. However, for water heating, this matches population-based estimates a lot better. Cool. We also said that Dunedin and Wellington are pretty similar as well, with Dunedin in fact having more space heating demand despite having less population than Wellington. So looking at our device fuel split for 4 main cities, we also further did this by detached houses and joined houses, just to add some extra accuracy, and how the different devices are used. And so you can see we have, in the North Island, like Auckland, there's more natural gas than in Christchurch. And then similarly, if we compare Wellington and Dunedin, there's a larger component of natural gas in Wellington than Dunedin, simply because natural gas is a lot more available in the North Island than in the South Island. So these heating devices affect the efficiency of the heat output and the greenhouse gases. So our annual emissions, when we look at both space heating and domestic hot water, again, follows similarly to that space heating demand, though you'll notice Dunedin has dropped from 3rd to 5th. And again, the domestic hot water follows population much more than the space heating. Cool. But if we look at the emissions normalized by other metrics, on the left we have the emissions per square meter, and on the right we have the emissions per kilowatt hour of heating. And so this paints a bit of a different picture where we can identify regions that have a lot more emission intense heating. So those things like Queenstown, where it's a lot colder, or areas where natural gas is used more, so it's more emission intense. So finally, we looked at a scenario where all the remaining fossil fueled space heating and domestic hot water was electrified. And so this map shows the percentage reduction in emissions if this was done. And so that ranges from 18 to 55%, where those high gas regions and the West Coast, where coal's used a lot more, have some of the higher percentage reductions. So this could be used to inform regionally focused efforts to decarbonise the way we heat. And finally, the seasonal kind of variation for national winter demand we have here for the whole country in the top, and the next two are Taranaki and the Manawatu-Whanganui regions, where that gas use meant there was a really large percentage reduction. It does obviously mean we have more electricity demand, however, and you can see those seasonal peaks could in fact be made larger, which may cause issues. So we have a 16% nationally kind of increase in that seasonal peak, and then but up to like 37% in some of those more emission intense regions. Cool. So to summarize, we developed a method that took one national annual heating demand, and it spread it out and distributed this across New Zealand regions and across fuel types. We validated this against the electricity data and found good agreement, and we also calculated regional emissions. And then ways we could use this to identify emission-intense regions, which again could be useful for future planning of targeted interventions where we could have the biggest effect. And we looked at the electrification scenario and some of the things of that. Cool. And that's all. Thank you.
Thank you. Obviously, you took a quick whiz through the method, but would it be possible to make the estimates at a lower scale of geography using more detailed census data? So below regional level?
Yeah, so we actually did this for territorial authority. So we had 66 of those across New Zealand. And so if we go, this was done for each territorial authorities, and this is just the 10 highest demands, but we do have that data. It's just lower than that. I think you could. There's certainly some of the dwelling statistics for that. The temperature-based data is not necessarily as granular and as easy to incorporate. But you certainly could, I think, yeah.
Okay, please join me in thanking Hannah.